All right, guys, so we know how to determine if two lines with general equations are the same line by looking at those general equations. So the question now is, how, when I'm given vector equations of lines, do I determine if they represent the same line or parallel lines or different lines? So we're going to do this problem. Which if any of the following lines are the same as this given line right here? So I'm going to call this given line L, and then A will be L1, B will be L2, and C will be L3. And before we start this problem, we're just going to think about what it means for two lines to be the same. So let's just take a look at some lines really quickly. If I have two lines that are parallel, notice these two parallel lines, they have the same slope, and they have no points in common. They never intersect. Well, when we think about that in terms of vectors, having the same slope, remember, is like having the same direction. And if they have the same direction, that means they'll have the same direction vector that is parallel. So direction vector. So I could have those two parallel lines. I could have two lines that are not parallel. So maybe they intersect at 90 degrees, like maybe they're perpendicular, but maybe they just intersect at some point. So these are not parallel. And notice, if two lines are not parallel, they can intersect at most one time. So this goes to the idea of, remember our first theorem, that two lines can intersect, or linear equations can have either one solution, no solution, or infinite solutions. So here this parallel is no solution. This right here would be one solution. So this is different slope. So if they have a different slope, in other words, they have a different direction vector, and they'll have one point in common. So then the third possibility when we have two lines, this would be our infinite solutions, would be if those two lines are the same line, and it's really hard to draw two of the same line, would be if they're the same line. So this is the same line, and if they're the same line, then of course they have the same slope, which would mean they would have the same direction. And they have all of the points in common. So in other words, to be the same line, all that has to be true is that the slope has to be the same, and they have to have every point in common. But if the slopes are the same, then either they're parallel or they're the same line. So if they even just have one point in common, they have to be the same line, because that means they're not parallel. So if they have the same slope and one point in common, we can tell they are the same line. So then the question becomes, when I have vector equations, how do I determine if these things have the same slope and if they have one point in common? Well, we know that this vector right here, the t vector, the 2, 8, -4, that's my direction vector. And I know that two direction vectors, or two vectors in general, are parallel if they're scalar multiples. So the first thing that I want to do is just look at these and check if any of these have the same direction. So are their direction vectors scalar multiples? Are the direction vectors scalar multiples? And if so, they represent the same direction. And that's not a question mark, that's a period. So that's the first thing we want to check. Are the direction vectors scalar multiples? If so, they represent the same direction, so either they're parallel or they're the same line. Then the next thing we'll need to check is, if they are parallel, if they have the same direction vector, or their direction vectors are parallel, is the point on one also on the other? And if so, they're the same line. Okay, so let's do this. A. Well, what I'm looking at here is my direction vector for line 1. That's 2, 8, negative 4. And my direction vector for the original line, L, and my direction vector for line 1, which I'll call D1, is 3, 12, negative 6. Well, I can see by looking that yes, these are scalar multiples. If ever you're unsure, you can always just do D1 divided by D. So in other words, the thing that I would have to multiply by, the first component in D1 is 3, the first component in D is 2, so it would be 3 over 2. So in other words, what I'm looking at is 3 over 2 times 2, 8, negative 4 equal to 3, 12, negative 6. And the answer here is that yes. So 3 over 2 times 8, that's 12. 3 over 2 times negative 4, that is negative 6. So here the answer is yes. So either they are parallel or the same line. So here, that was our step 1. Now let's check the point. So I'm going to check, is the point 1, 1, 1 on L1? So here, to do that, remember we write our parametric equation. So I would have x is equal to 2 plus 3t, y is equal to 0 plus 12t, and z is equal to 4 minus 6t. And then I'm going to plug in my 1 for x. So 1 would equal to 2 plus 3t, which would mean t would equal to negative 1/3. Y, if I replace my y with 1 now, I would have 1 is equal to 0 plus 12t, which would give me t is 1/12. They are not the same. The point is not on the line. So in this case, we can see that they are parallel, but not the same line. Okay, so that was A. Now for B, I'm sorry, I'm gonna have to skip down here. For B, I can see that the direction vectors are actually the same vector. I have the 2, 8, negative 4 and the 2, 8, negative 4. So now all I have to check really is the point. So in this case, I can actually say D is equal to D2. They actually even have the same direction vectors. They're not even just scalar multiples. So then I'm checking the point. Is 1, 1, 1 on L2? So now I'm going to rewrite L2 as the parametric equations. So that's x equals 3 plus 2t, y equals 9 plus 8t, z equals negative 3 minus 4t. X equals 3 plus 2t, y equals 9 plus 8t, z equals negative 3 minus 4t. And so here I get 1 is equal to 3 plus 2t. So in the same way as we had before, 1 minus 3 is negative 2. So t would be equal to negative 1. 1 equals 9 plus 8t. And again, this gives me t equals negative 1. And here 1 equals to -3 minus 4t. And guess what? This also gives me t equals -1. So these are all the same. So the point is on the line. These are the same line. They are parallel and they have a point in common. Okay, so then let's just look at the last one, C. So with C, my D is still equal to 2, 8, -4. So then my D3 is the direction vector of my line 3 here, 8, -32, 16. So I can see that in order to get from one to the other, I just have to multiply by 8 over 2, so that's 4. So in other words, is 4 times 2, 8, -4 equal to 8, -32, 16, question mark? And the answer is no. The direction vectors are not parallel, which means we don't have to check the point. These are not the same line. Not parallel. No need to check the point. These are not parallel and they are not the same line. And that's my final answer here. And it turns out that we had 3 cases and they were each of these 3 lines. So in this case, it turns out that my A looked like that, my B looked like that, and my C looked like that. And that is how, when we have vector equations, you can determine if 2 lines are the same line. That's all. Bye, guys.